Thank you. Good morning to everyone. It's a pleasure to be here. We're going to change gears maybe a little bit from what you guys spoke about yesterday and the review we have this morning. We're going to talk about a project that we have going near Fort Collins. We've completed 3 years of field work over there, and we're going to talk a little bit about that. In this presentation, probably not going to focus as much on some of the soil aspects and try to cover some of the practical information, things we've learned, and also bring in a little water quality information and talk a little bit about the relevance of water quality. This is kind of an interesting project. Actually, some of the folks that have been there from day one are here, and you'll be hearing from some of them later. But this project was a nice one for us at the university. In that it was driven by folks other than the university researchers. We certainly had interest, but we had producers and industry folks come to us and say, we need more information on conservation tillage, on furrow irrigated ground, on flood irrigated ground. And we need some information we can share with our banker and with our colleagues and our landlords to advance these systems, because we think it's something that should be adopted. And so we've worked really closely. We have an advisory committee made up of producers, conservation district staff, and industry folks that kind of keep us on the right track as far as the work we're doing, trying to come up with some practical information for the group. Go ahead. So some of the goals of the project, some of the things that we sat down together and came up with as things that we wanted to come out of this work. The first one, the first bullet point there up top is probably the most important. It's these systems are good. This is one of the conservation tillage gets promoted a lot in conversations about soil health and conversations about water quality. But for us, we really wanted to find out how viable these systems are. What kind of yields are you going to get? What's your bottom line going to look like? And so we were trying to produce some information that would help answer that. And then as part of that, when you're doing conservation tillage, you're not burying the residue. You're going to have more on the field. And how to deal with that residue. So that's another thing we were looking really closely at. And then Troy and I both work in a water quality program. We're very interested in sediment loss and nutrient loss off of any field, but we wanted to look at what those impacts are on conservation tillage fields when you're flood irrigating. And then again, back to the economics, it was the farmer and conservation districts, industry folks that came to us. It was kind of interesting. We had economics as kind of an aside, something we weren't really going to focus on all that much. And pretty early on in the project, we sat down and they said, you got to tell me how this is going to work, how this system is going to affect my bottom line, because if I can't make money, I'm not going to do it. It's obvious to anybody that's a farmer in the room, but sometimes as researchers we forget that, because we still get a check even if our yields are terrible. So that was a good reminder, and that's part of why we focused on that in our project. So. Some of the questions that came up as part of this conversation, just to get down a little more to what exactly we were after. Can I make money? Can I irrigate without getting out the shovel in conservation tillage when you're trying to flood irrigate? Obviously, you're always going to be doing a little shovel work in any irrigation system, but of course we wanted to look at how we can minimize that. We'll talk about that in a little more detail. And then again, providing some economic information that you can go to a banker and get a loan for a strip till unit, or some of these other implements you may need, and how to have a conversation with your landlord about, well, my costs are going down, my yields may also go down. How do we make that beneficial for both the tenant and landlord if you have a rental? And then there are certainly other questions that came up, and others we'd be interested in hearing from you guys. So this is just to give you an idea about where we're located. The RDEC field site, that upper right bubble there, that's where the main field site is. Most of the data I'll be presenting is from there today. And then we work with more than these 4 farmers, but this is just to give you an idea about where some of the guys that are doing some of this conservation tillage on flood ground, where they're located in and around the Fort Collins area. This is where our field site is. We have 3 different tillage treatments that we're comparing, and again, we've done this for 3 years. We have a conservation or a conventional till ground, which is basically we're just trying to represent local practices, and this is in consultation with the farmers on our committee, what they do on their farm when they're going to have conventionally tilled, moldboard plow, full full tillage operations. We have that there as a comparison. Then we have a plot that we call minimum tillage. It started out, we were trying to do no-till on furrows. I'll talk a little bit more about why that's maybe not a good idea, or at least the way we were doing it didn't work out so well for us. And then we have strip tillage, and strip tillage is probably our most promising system, and that's one I'll talk about in more detail here. These plots, again, the farmers made it pretty clear early on they didn't want to see a typical, small-scale research plot that's 100 feet long. They wanted something that's a little more realistic. So these plots, it's not a half-mile run or anything, but these are 1,100 feet long. Our plots are 36 rows wide. These are 30-inch rows, so 36 rows wide. Trying to do something that's a bit more field scale, so we can, if we can get water 1,100 feet, you can probably get it a little bit on a longer run. We just didn't want to do something that was small, so we made them field scale. And then just a couple other things to give you an idea where we're at. It's about 5,100 feet, almost 5,200 feet where we are. So as far as growing degree days for corn, we get anywhere from 23 to 2,400 days. So we can deal with a 93 to 95 day grain corn. And so just to give you some perspective. We've done continuous corn. We did 2 years of grain corn. This last year we just came out of silage. We did continuous corn basically because we wanted to make it as hard on ourselves as possible as far as volume of residue we were producing on the field. And that's basically just to say if we can irrigate with this much corn residue, you can certainly do it if you're doing maybe a more reasonable rotation. A lot of the guys we work with are doing this sort of thing with silage corn, putting in some winter wheat, something that's going to reduce that residue pressure a little bit, but we want as much residue as possible. So within this plot, within this system, we're tracking, we collect large amounts of data. We had a dedicated graduate student on this project. Data as far, we do pull soil samples at least 2 times a year, run routine fertility and deep salt nitrate. We do a lot of measurements on water quantity and quality on this field, and then all the agronomic parameters, yield components, all those sorts of things. So we have a lot of information on this project. We won't talk in a lot of detail about these operations, but this will just kind of give you an idea of our 3 treatments and the sorts of things we do. The operations we're going to look at for the 3 treatments are actually from 2012, which was kind of an odd year. So you'll see in there we have packed beds and we have packed furrows twice. Well, 2012 was a pretty brutal year, especially in the spring from a drought standpoint. It was incredibly dry, and we, along with everybody else farming in the area, was really struggling to get crops up and to get water down the furrows because things were so powder dry, water was just going down, and it was a real nightmare. So those extra operations, that's not something we would do every year in this system. Those were there so we could try to get our crop up, which was some struggling we did. This is just to give you a perspective on the field. On the right, on the right side, that's one of our conventional till plots. That's obviously recently been plowed, and then on the other side, on the left side of the screen there, that's our minimum till plot, which will basically be left alone until planting. You can go forward. This is what we did in the minimum till. Basically, you can see significantly fewer operations. This plot, it's one redeeming quality. Trying to do this kind of treatment, this thing irrigates incredibly well. Part of that is because we're not disturbing the soil, but we also have fairly compacted not beds, but furrows, and so water moves through there pretty quick. Residue is really not an issue as far as getting water to advance in that system, but it has some other challenges that we'll talk about. This is our strip tillage plots. There's the operations you can see pretty similar to the min till. We did have to pack it, and then obviously there's a strip till operation within the system. The way we're doing this, you're going to hear from some other folks that are doing things a little bit differently that also work well, but we've had pretty good success with this system. Basically what you see, this is a picture from 2012. 2011 corn stalks are off to the left there. We offset our strip tillage operation 4 to 6 inches. and then plant into that strip. So we're basically just offsetting, still planting on the top of last year's bed, but offsetting just to the side of the previous year. And then you can see also where that crop row is right next to there is where we put our residue. We sort of mulch it, and then we irrigate the other row. So we're doing some every other row irrigation. This is just after strip till in the fall. You can see where the strips are, and then there's pretty significant residue still left on the field to go forward. So after that, one way we're dealing with the residue in this continuous corn system with the pretty high volumes of residue on the field, one thing we do is chop and bale in the fall. That's something that is incredibly common now with the prices you can get for corn stalks, especially in 11 and 12. So a lot of guys were doing this and stripping it pretty clean. We intentionally didn't strip it clean because we wanted to leave some residue behind to give us something to work with, and also to leave that cover on the ground to get the benefits of the residue. So this is just some tonnage of residue left. We had a significantly better crop in 11. So when we went into 12, this is residue cover on the ground at planting. So this is after that chopping and baling operation. Part of the reason those minimum till plots have significantly more residue left on the ground is because we've had some issues we've had disease problems, and we've also had some planting issues in the minimum till treatment. And because of that, in the fall, we've had some significant lodging. And lodged corn, as most of you know, is a lot harder to pick up than corn that's standing up. So we had a lot more residue in those plots. This is the way that we're dealing with residue in both of our conservation tillage plots, minimum till and strip tillage. Those are just row cleaners, Acre plant trash whips, they call them. They're meant to go on a 2x2. We've just got it on a shank there. We run that unit down the row that we're going to irrigate. You just set your speed about right. I'm probably going about 5.5 here. Then we throw our residue up into these alternate rows, our mulched furrows that we do not irrigate, and then you irrigate this row. So it's just you set your speed right, get that residue up and over. You see, throw a little bit of soil with it. It helps hold that residue down, and then you have a relatively clean row to irrigate with. You can kind of see this is sort of the after effects here, just after that row cleaning operation. So getting into some data now, this is one thing that I think is pretty important. We've been pretty lucky to get some timely rainfall a couple years. I want to highlight in 2012, this is inches of water, total inches of water in the top 6 inches of soil. So basically where you're going to plant, and then where that root, after germination, where that root's going to pop out and start looking for moisture. This is in that top depth. In 2012, step back here a little bit. In 2012, this became pretty significant. As I mentioned, 2012 was a really tough spring. In our strip tillage plot, had a little over an inch more moisture than we did in our conventional till plots. Both our conventional and our minimum till because of seed placement couldn't get it deep enough. We had to irrigate both of those up, and we'll look at some numbers of irrigation application amounts, and you'll see what kind of impact that really had. Strip till, we did not have to irrigate up. We were able to just let it germinate and emerge on its own, and get a good head start on the season. And that becomes a big deal when you're paying to pump a well. This is all irrigated with a well. So there's some significant savings in pumping costs, but also just the labor and the struggles we had trying to get those other 2 plots up. Having that extra moisture in the strip till treatment from not disturbing that soil and kind of leaving it alone in the spring really was a big advantage for us. So one of the big questions, as I said, is can you irrigate these fields? Can you get water through? And so irrigation advance times, this is something we track from the time we set a siphon tube. We set all the siphon tubes in a plot till the time that the majority of those rows get to the end of the field, so the end of that 1,100 foot run for us. And in general, you can see, for those of you that are interested in stats, you can see none of these are significantly different, basically meaning that all of those in general irrigate about the same. And none of those, you can see none of those took us up to even 2 hours to get the majority of the rows down through the field. So, you know, depending on the irrigator, you might think that's even too fast. And so advance times for us have not been an issue getting that water to go through. That's not to say, however, we haven't had some trouble, and there hasn't been a little bit of shovel work, because there certainly has been. But I would not fault the system. It's been kind of the issues have been with our planning and sort of the way we're doing things. Some of the guys you're going to hear from a little bit later have worked out some solutions for these kind of problems, and we'll talk about that later. But go ahead. So total inflow, again, bring your attention to 2012. That conventional till plot, these are in total applied acre inches. So this is acre inches that came out of the siphon tube, basically, not what stayed on the field, obviously. So pretty massive difference from the conservation tillage plots to the conventional plots. And that was for two reasons. That was for the dry soil in the conventional tillage plots, and the fact that we didn't irrigate up the strip till plots, it did it on its own, and then the fact that we were having trouble with advance while we were packing those furrows and trying to get that water down. So we basically had to run water for a significant amount of time on conventional till that we did not have to in either of the conservation tillage plots. So I'm going to talk a little bit about water quality, and there's quite a bit of data here, but I'll just try to touch on some of the key points. Water quality is important for a number of reasons, and because of that, we have done some extensive sampling on this. This was funded, I should mention, by the NRCS. This was a conservation innovation grant, and one component of that they were interested in was the water quality parameters, and so we're tracking that also fairly closely. Go ahead. So why is this important? I think most of you are familiar with water quality issues we have in the state and around the country. Obviously, nutrients are important for us that are trying to produce a crop. Nutrients are absolutely necessary, of course nitrogen and phosphorus especially. But excess nitrogen and phosphorus in water bodies, surface water bodies, can become a real problem. They lead to eutrophication and algae blooms. You get these conditions where you have fish kills. That's when it obviously makes the news. You have these big fish kills. They make these scary pictures, and everybody freaks out about it. But it's an issue before you get to that point. That photo in the top right there, that's from Fruit Growers Reservoir, which I'm sure many of you here are familiar with. It's nearby. It's actually an impaired water body. It's listed by the EPA and Water Quality Control Division to have issues with total phosphorus and dissolved oxygen, so it's got some issues. And as you'll see as we look a little more at this data, things like total phosphorus and certainly sediment are things that can be reduced by conservation tillage, and so taking some proactive steps in agriculture, I think, is a good way to get kind of ahead of the game before these problems get more severe and before folks like EPA come down and want to put their hands in it. We can take some steps ahead of time to really make some impacts on these things. So this is just to show you, this is data from Department of Public Health. This shows you, this is nitrogen. These are average loads these are concentrations, these are average concentrations in different watersheds around the state. You can see the Gunnison there, Colorado. Basically, you don't need to worry about what the numbers are, but the darker colors are higher concentration. The darker numbers are closer to what there's a possibility of them looking at trying to take some action on. You can see, obviously, over in the South Platte and then down there towards Pueblo, they have pretty high concentrations, and that is, well, it's pretty obvious if you think about where the population in our state is. That's not necessarily related to agriculture entirely. The majority of that's coming from wastewater treatment plants in both of those locations. And you can see we do have some elevated nitrogen over on this side of the mountain, although the problem is certainly greater over on the other side. Total phosphorus is kind of a similar picture. We probably have fewer problems with total P, especially over on this side. But again, we have some water bodies like Fruit Growers Reservoir that have already been listed as impaired, and they're taking some steps to try to mitigate that. So for us, for our water quality sampling on these fields, we're looking at total phosphorus, total nitrogen, the soluble components of both of those, ortho P and nitrate. And then we also did some work on herbicides, which produced some interesting results. The work that Troy and I do focuses on both fertilizers, all forms of agrochemicals, fertilizers and pesticides. So this is a picture. That's our grad student out there in the field with putting a little weir in there, pulling a sample. We pull samples for both sediment and then run nutrients on those. We pull those at different intervals throughout the season, and then analyze those. And what we're looking at is the difference between these treatments. What kind of impact can we have on water quality using conservation tillage? And obviously that's tied directly to soil. Water's not brown for no reason. It's brown because it's pulling sediment out of your field and moving that topsoil somewhere where it's not going to be as productive. So the two are definitely linked. So just looking at sediment, this is concentration, it's just the amount within the water, and then load is the total volume. These are in metric, but those numbers, if you're interested in the numbers, are pretty comparable to pounds per acre. Concentrations, as you can see, especially in 2011, really we were able to bring those down. The two conservation tillages are the two green bars, and then the other one, the brownish bar, is the conventional tillage. So we were able to make an impact, but as it says there, where you see in 2012, that center bar in concentration is significantly higher in minimum till. That's in part, as I said, we have those compacted rows. The water's really screaming through there, and because of that, we're picking up some more sediment and having higher concentration. Something you don't necessarily expect in a conservation tillage field. When you look at the total numbers, there's kind of similar information. The total load in both years, if you look at those as pounds, is pretty significantly reduced. Not statistically significant, but there is a reduction from conventional till and the two conservation tillages. We're able to reduce the amount of nutrients that we're losing off the field. Again, we have our year 3 data. We're in the process of analyzing that. I think when we throw that in here, you're going to see some more clear trends and some more useful data that we can share on the water quality impacts of these systems. And then you look at those soluble components. Coming again with the data we have currently on concentrations there. The significant differences are not there. 3 years of data may change that, but we have some good information on these impacts. So. Just briefly to show this is a slide that kind of surprised us actually. This is looking at herbicides. The interval is just those sampling times, whether it was at 30 minutes, 120 minutes, or 240 minutes. And then we did it on 2 irrigations, conventional till, minimum till, and strip till. This is atrazine and metolachlor are the 2 bars in there. A lot of times people expect there's a number of papers out there that show in conservation tillage, you can have higher loss of herbicides and pesticides out of your field because more of that stick as you're spraying, it kind of makes this logical assumption. You're spraying this herbicide or pesticide on top of the residue, irrigate that, it's a lot easier to wash off and wash down the system. Well, the results that we found are not showing that. In fact, they're showing significant decreases in herbicide and pesticide loss, especially with atrazine and metolachlor. And so this is something we may pursue further because that, I think, could be a beneficial outcome of this work. So just a brief summary on this. The only things that significantly decreased total P and metolachlor was statistically significant also. Again, total P reduced in the conservation tillage systems. So this to me is interesting in this area, looking at a place like Fruit Growers Reservoir that's got a total P issue. And total P is something that they're looking at, and showing that we have ways to reduce total P loss, I think is important. And again, I think the 2013 results on our water quality will probably give us a little bit clearer picture about exactly what's happening here. But I think what's important to keep in mind is that when you're talking about soil health and conservation tillage, the impact of water quality is also very important, and I think those results are equally as important to the system. It's all part of the same system, and keeping water quality in mind with your soil quality, I think, is very important. So now I'll get into some of the maybe more important conversation. These are, so as I said, we had 2 years of grain corn and a year of silage on this study so far. We're going to continue into this year and probably do silage going in. This is looking at our 2 years of grain corn yields. You can see the 2-year averages down there on the bottom. Conventional till and strip till are basically spot on with one another. Minimum till, as I said, has had a number of problems, and as part of those problems, our yields have taken pretty significant hits. 2011, we had some stand establishment problems, we had some lodging problems. That's what hit the yields there in the minimum till. And then 2012, we had some disease issues that I'll touch on briefly also. This is our silage yields from this year. These are pretty comparable yields for the area. I think we did fairly well, but again, took a pretty significant hit in the minimum till plots. But got pretty decent tons per acre quality. We haven't fully analyzed that yet, but we do have all the quality information from these samples as well. Let's go on to the next one. So I think the main point here is, from a yield standpoint, is strip till out yielded conventional 1 year, was a little below another year, and then pretty comparable this last year. This is just a comparison. It's a way to look at yields when you have two different types of crop, grain corn and silage corn. We're just basically taking the conventional till as our standard and dividing that into the other treatments to see sort of how they stack up. So basically a number of 1 means it's equal to, conventional till is obviously equal to itself. So strip till, I actually put 3 significant figures in there, 3 decimal places, just to show you that there is a slight difference between strip till and conventional till. There is a 0.004% yield hit, basically, in our strip till system. But as you'll see when we get to the economics, that's not
oh, I'm sorry.
significant. No, that's fine, you can go forward.
Okay.
So now we took this a little bit further, and we wanted to look at the economics. So we've got the yield, we know all the input costs, we know what we did on the fields, and we want to look at how those numbers pan out, what that looks like from a producer standpoint. If you were going to try to do this system, how could you make it work? And so we tracked our actual fuel use. We had guys topping off their tanks before we'd run up to the field and do our tillage operations, tracked our irrigation times, basically kept track of any input costs you need to look at if you were using this system, and then compared those using current annual prices, fuel and commodity prices. And we're in the process now of going into a higher level of detail with an economist, a PhD student that's working with us. And we're going to get into some more, I'm not going to present detail, but some of the things I mentioned, like landlord-tenant relationships, how those arrangements work if you're sharecropping or you're just a cash lease, and how a landlord, if he sees a tiny yield hit on a conservation tillage plot, how you're going to convince him that that's a good idea. And so we're going to have some of that information available. Go forward here. So just quickly to show you the costs. Costs in conventional till, that's again conventional till, strip till, and min till from left to right on those bars. Costs in conventional till are higher. No big shock there. Just to break it down a little more, why are those costs higher? Well, again, it's kind of common sense. You're not out on the field, you're not burning as much diesel, you're not buying as much diesel, and then you're also putting less wear and tear on your equipment when you're using these systems that require you to be on your field less often. So this is looking at our gross revenues. This is a 3-year average, so this is the 2 years of grain and a year of silage. What we got on an annual average, so on average for 3 years, and each year, that's what we made in the gross revenue. Take out those costs we were just looking at in the previous slide, and then the 3 smaller bars to the right are our net return. So that's our gross revenue minus all of our costs. And and we're incorporating insurance and labor and basically accounting for everything you have to account for when you're trying to run a farm, so that all those costs are taken in. Our net, so this is a net return per acre, conventional till, strip till, and min till. And you can see, as I pointed out, we had a very small yield hit, if you want to call it that, in strip till. Insignificant, really. But when you equate that you're going to have lower costs, you end up about $70 more per acre in strip till on a 3-year average. And again, this isn't a guarantee for every farm in the state, but this is what we found on our farm. And I don't think these numbers are too out of whack with work that was done by Dr. Calvin Pearson over here back around 2000, and other studies that look at these conservation tillage systems. So just real briefly, a few other considerations. Disease I'll talk about in just a second. You have to keep in mind your weed control is going to be a little different if you're not consistently burying these things. Again, we had some lodging problems, but I think that was a product of what we were trying to do and not necessarily the system itself. And again, that was only a minimum till, strip till. We had no lodging issues to speak of. We feel pretty strongly, we've been using guidance for all 3 years, a little bit more advanced guidance the last 2 years, just to get everything straight, get our strip till operation straight, and get us through the field, and we think that's pretty important. Neighbors, I just put that in there. This is one that's come up in conversations when we present at things like this. If you have more residue that's sitting on the surface, it's not buried, and it blows, it's not unusual to get a phone call from a grumpy neighbor, especially over in our neck of the woods where we have agriculture right next to urban development. And so that's just something to keep in mind. Compaction, I'm not going to spend much time on this slide, but compaction, conventional till, minimum till in the middle, and then strip till on the end. The important one, at least initially, is the bed, that center one in each of those. These are numbers in kilopascals, but you can look at in the strip till bed, there's significant reduction in compaction that we have where that seed is going to germinate and try to grow. And then there's some of the more serious compaction in min till that's given us some problems. And then you look at where conventional till matches up with that. But compaction when you're not treating your soil is something to just keep in mind, keep an eye on.
Oh, gosh, sorry.
No, go ahead.
I'm thinking you're going forward.
No, go ahead. I'm swinging my arm around. This was 2012. We had a pretty significant hailstorm. You can see tore up the corn pretty good, didn't strip it bare. This is taking a look at the minimum till plot. If you go to the next slide. So shortly after that hailstorm, we had a really significant outbreak of Goss's wilt, something that we don't really see very much over there. It's pretty rare, especially as far up to the hills as we were. But this Goss's wilt, these pictures are all from minimum till, where we had significant residue on the surface. Goss's wilt is something that's known to survive pretty well on surface residue that's not buried. In strip till, this was fairly minor, and then in conventional till, we saw almost none of this. So disease is certainly something you have to be aware of, and you have to keep in mind when you're leaving this residue on the surface. It's going to change the dynamic of these disease pressures, so that's just something to be aware of. I'll go through these real quickly, just let you look at them. You're going to get some good information from the folks that are going to come up shortly after Troy and I on some real practical things related to these operations. But some of the things we've learned how to deal with residue, as I said, we're doing every other row irrigation, but Dave and some others have some really good ideas about ways that you just move that residue to the shoulder, and then you can irrigate every row. It's just kind of a different way to do it, but you have to get it out of the way enough that you can run water through the field. And again, we're doing continuous corn. I probably wouldn't recommend that if you're going to try these systems. Crop rotation is important. And taking time to get your strip till operation right, if strip till is what you're going to do. Make it straight, make it on the bed where you want it. Don't let it move around because it'll give you problems with cultivation, and the whole rest of your season will be a headache. Fertility, basically any fertility system still works in these systems, although if you're doing something like a pre-plant broadcast, you're not going to be able to incorporate it the same way, so that's something you need to think about. We do starter, 2x2, and side dress. Weed management's another one. Probably one of the most important ones is this down here at the bottom, be ready to irrigate up if needed. This, I think, has been one of our biggest, I don't know if mistakes the right word, but things that we are going to change. And some of the other guys, some of the producers you're going to hear from this afternoon, will, behind their strip till operation, run a ditcher, basically. So you're ready to go if for some reason you don't have the increased moisture we talked about, or you have a year where you need to irrigate to get that crop up. You want to be ready to do it, because there's a couple years we haven't been ready to do it. We try to pull a little mule shoe or something through the residue, ends up knocking over corn plants, and it's just a real headache. So be ready to irrigate up. I think that's a really key. I think that's a really key point. Hope that you don't have to irrigate up, but be ready to do it if you need to. So we have just a few conclusions. This certainly, transition to this isn't necessarily easy. You have to be a little creative. You have to be used to seeing things you're not used to, and come up with some ideas to fix some problems that you maybe haven't encountered in the past. And you're going to get some great ideas later today from folks that have a lot of experience with this. And do what works. One thing we did in our minimum till plot, I think, was trying to stay a little too consistent to the system. If something's not working, do something else. Again, water quality is important, and I think the end message is that there are ways to make conservation tillage work economically and agronomically in furrow irrigated fields. But again, not every furrow irrigated field, and you have to come at this understanding that things are going to be a little bit challenging, or at least potentially can be. Just kind of a heads up, we're finishing this study up. We're going to be putting out a revised technical bulletin that Dr. Calvin Pearson from Fruta put out. He's going to work with us, so we're going to put in all of our data and come out with kind of an updated version, some more of the economics and a little probably water quality information. That'll be coming out this summer. And then our website is currently functional. It's since the student graduated and moved on, it's been neglected a little bit. But by this summer, this is going to be populated with everything, all the information here, plus a whole lot more that we have from the study. These are pictures of producers that we work with, their fields where they're doing conservation tillage, maybe doing things a little bit differently than we are, but they're making it work, they're making money at it, and that's just kind of just a reminder that you can make it work. A lot of guys are doing it in our area and being successful with it, so some of whom you're going to hear from. And I believe that's it. So I'll stop there. I should mention just quickly, so Troy, I don't know where we are on time, but Troy Bowder is now going to come up. He's going to present, change gears a little bit again. What we use to schedule our irrigations on this field, in addition to soil moisture and going up there and poking around, we have an online irrigation scheduling tool that's relatively new, and Troy's going to discuss that and give you a little demonstration on that. So I can take questions now or after. Or
do we have a question for Erik right now?